Alright, in today's lesson, we're looking at factored form and the zero product property. Our objectives will be to understand what factored form looks like and to understand the zero product property and how it's used with roots. The vocabulary for this lesson is factored form, polynomial in the form y equals a times x minus r1 times x minus r2. Zero product property, making x minus r1 equals 0 and or x minus r2 equals 0 will give you the roots. We'll start first with the basics. What is factored form? Well, factored form looks like this. And in this form, a is our a value. This is, if you remember, what tells us whether something is going to open up or open down with our polynomial. So a positive a gives us a polynomial that opens up. A negative a value gives us something that opens down. R1 is one of our roots. R2 is our other root. So what we've got here is a setup that allows us to identify the roots very, very simply using something called the zero product property, which I'll now show you. The zero product property basically says that if a equals 0, then y will be 0. If x minus r1 equals 0, the whole thing equals 0, then y will be 0. Or if x minus r2 equals 0, then the whole thing would be 0. This is because we're multiplying between these three parts. And if we multiply 0 by anything, we always get an answer of 0. So what we're saying is, this is a way to find roots, because a root, as we know, is an x-intercept. All roots are of the form x, 0. So if we can find some way of making values equal 0, we can get a y of 0 in this form because of the multiplication. I'm now going to show you the actual process of doing this. Example 1 here. We've got y equals 2 times x minus 7 times x plus 5. Well, 2 cannot be turned into 0, so that one's off the table. But we can look at this. X minus 7. If we set it equal to 0, we will then get a 0 in that parentheses. And multiplying by that parentheses will cause our y value to be 0. Then we have a root. We're going to add 7 on both sides and get x equals 7. Therefore, if we use the x value of 7, this problem will end up being 0. So we know one of the roots is 7, 0. Our second problem here is we can make this one equal to 0. Again, if this equals 0, the whole thing equals 0, giving us a root. We're going to subtract 5 on both sides in this one and get x equals negative 5. So our other root is negative 5, 0. I have a second problem up here. This one's a little bit more complicated. What we're going to do is we're going to first look at the x. This x is in the a value, which means it could be 0 because we could put a 0 in for x. So x equals 0. Well, there's no math on this one, so what we've got here is the possibility of one of the roots of this problem being 0, 0. Then we can take the second part here and go x plus 6 equals 0. Subtract 6 on both sides. X is negative 6. So we have a root at negative 6, 0. But in this one, and this is the tricky part, is there's actually a third situation that can be turned into 0. 2x minus 3 equals 0. We're going to add 3 on both sides. Get 2x equals 3. Then we're going to divide by 2 on both sides and get x is 1.5, or 3 over 2, or 1 and 1/2, however you want to write it. 1.5, 0. So in this one, we have 3 roots. In this one, we have 2. Thank you, and if there's any problems or things that you didn't understand from this lesson, please stop, rewind, and watch it again.